Hey guys, what is up? Today we'll be discussing some physics. So our agenda for today is briefly explain alpha decay, then explain positive and negative beta decay, gamma decay, and then nuclear fission and nuclear fusion. For starters, here's our key. Green will represent the proton, pink for the neutrons, and blue will represent electrons. So I'll explain what alpha decay is first. So let's say we've got plutonium, an isotope of plutonium, plutonium-240. When an object or element undergoes alpha decay, a helium nucleus is released. In this case, what would happen is we would lose 2 protons and 2 neutrons, and a helium nucleus would be emitted, and we would end up with an isotope of uranium, uranium-236. As you can see, the atomic number for uranium also changes to 92 and the mass number to 236. So a simple way to remember alpha decay is through this formula. If you have X being the element that's undergoing alpha decay, and if A represents your mass number and Z represents your atomic number, then we would get a helium nucleus, obviously, and then you'd get another element which you would take the mass number of your original element, subtract 4 from that, and the atomic number of your original element, subtract 2 from that, and using your atomic number minus 2, you would get the new element that is formed when X undergoes alpha decay. Alpha particles aren't particularly strong. They can be deflected easily by a piece of paper, so you don't really need much protection. Your clothing can most likely protect you. Now let's talk about beta negative decay. So let's say we've got an isotope of hydrogen-3, or known as tritium. As you can see, we've got 2 neutrons and 1 proton in this one. Let's say it undergoes beta negative decay. What would happen in this case is that we would get an isotope of helium-3, and an electron would also be released, as you can see over here. And if you notice, we have 2 protons and 1 neutron, and over here we had 2 neutrons and 1 proton, which means that as during beta negative decay, an element will tend to lose that neutron, which will transform into a proton and release an electron as well. Let me repeat that. An element will lose a neutron, and that neutron will be replaced with a proton and an electron, which will be emitted. So let's find the formula. The formula for this is that, let's say you've got element X undergoing beta negative decay. So what would happen is that you would get element Y, which has the same mass number. Mass number does not change in this case, but your atomic number gets bumped up by 1. You add 1 to your original atomic number. Also, you'll get an electron released. Now let's just talk about beta positive decay. So let's say we've got carbon, and let's say our carbon atom undergoes beta positive decay. In this case, we would get boron and a positive electron being released, or you might want to call it a positron. As you can see, we have lost a proton, which has turned into a neutron, and also a positive electron is released. Let me repeat that. A proton has been lost, yet we've gained a neutron and a positive electron has been released. So the general formula in this case is that, let's say you've got element X undergoing beta positive decay, and in this case what happens is that you get element Y, which has the same mass number once again. However, your atomic number gets bumped down by 1, so you subtract 1 from the original atomic number that you had, and you have an electron with a +1 charge, so positron. Now beta particles aren't that strong, yet they're stronger than alpha particles, so they can go through a couple of sheets of tinfoil or aluminum, but they can't go through very many sheets and will bounce off eventually. Now, gamma decay. Let's talk about gamma decay. Gamma decay is quite simple. Let's say we've got tritium once again, and it undergoes gamma decay. What's going to happen is that a photon will be released. That's it. That's basically it. Mass number and atomic number stay the same. A photon is released. That's basically it. So that's your formula. We get element X, mass number, atomic number. It undergoes gamma decay. You get element X again, mass number, atomic number remain the same. The element hasn't changed, but only thing that has changed is that we're adding a photon. A photon is being released. And gamma decay particles, the photons are quite strong. In fact, they can go through paper, they can go through aluminum sheets. However, they can go through a couple centimeters of lead before they get bounced off. Let's talk about nuclear fusion. Now, from the name, you can guess fusion is when you mix two things together. And in this case, let's say we've got a neutron and a proton and another neutron and a proton, the pair coming together. This is an example of nuclear fusion. You'd get helium in this case. Nuclear fission, it's just the opposite of nuclear fusion, except you're bombarding a certain atom with a neutron in order to break it apart. Just like that. Well, that's it, guys. I hope you enjoyed it. I hope you learned something from it. Subscribe below for more videos. Thanks.